Welcome to another session of Everyday Mathematics. Now, today's problem comes from MIT 2024 Integration B regular season. Our problem of focus is problem number 4, which is indefinite integral of 2023x plus 1 over x squared plus 2024. So this is an interesting problem. I think it lies within the moderate category. It's not very hard, not very simple. But before I jump into trying to solve this problem, I'd like to thank our subscribers. Thank you so much for the support you continue to give us. Without your support, I wouldn't be here. For our first-time visitors here at Everyday Mathematics, what we do is we just go around and about and look for interesting problems. We come back and share with you some of the solutions that we think do befit these problems. For those of us who are coming back but haven't subscribed, we do really encourage you to consider subscribing to our channel. So this problem, as you can see, I personally would be inclined to separate it into two different fractions. We would split it into 2023 x over x squared plus 2024 plus 1 over x squared plus 2024. So if we create this as two separate integrals, we have the blue integral and the green integral, the blue being 2023 x over x squared plus 724, and the green one being 1 over x squared plus 724. So we would solve this integral separately. I would personally be inclined to bring out the constant 2023, and then x can be expressed as half the derivative of x squared plus 24, which is the denominator. So as we know, with the integration, if you have a fraction, polynomial that's a fraction, and the numerator is the derivative of the denominator, and then the integral of that function would be the natural logarithm of the function in the denominator. So essentially, we can pull half out, and so we have 2023 over 2 times the natural logarithm of x squared plus 24 as the integral of the blue integral. Now, we can now move forward to try and focus on the green integral. And the best thing to do here, I think, is substitution. There is a direct way, if you're very used to integrating such functions, it will be intuitive enough to know what the integral of this is, but we're going to try and do it from the very basics. So we could say let x be equal to the square root of sin 24 tan theta, such that the x d theta is square root of sin 24 sec squared theta. And so therefore we can substitute dx with square root of 2024 sec squared theta d theta. So this dx here. Now this integral now becomes one of the integral 1 over x squared plus sin 24 could be equal to 1 over, in place of x, we have the square of this, which is 2024 tan squared theta plus sin 24. And then in place of dx, we have the square root of 2024 sec squared theta d theta. So the denominator, we can factor 2024 out, and so we have 2024 plus tan squared theta plus 1 in the denominator. And so pulling the tan squared theta plus 1 is the same as sec squared theta. And then we can pull the constants out. So we have the square root of 2024 over 2024, integral of sec squared theta over sec squared theta. And so the sec squared theta obviously would cancel with one another. And so the division of square root of 2024 by 2024 is the same as 1 over square root of 2024. And the integral times the integral of 1. So this becomes 1 over square root of 2024 theta plus the integration constant. Now, since we said x is equal to square root of 2024 tan theta, that means that theta is equal to, when you divide both sides by square root of 2024, so we have x over 2024 equals tan theta, and therefore theta is the arctangent of x over square root of 2024. So what that means essentially is that this integral being this is the same as the integral of 1 over x squared plus 124, the same as 1 over square root of 124 plus of theta, we have arctangent of x over 2020 square root of 124. So this now can be substituted back to the original integral of 2023 plus 1 over x squared plus 124, being equal to 123 over 2 natural logarithm of x squared plus 124 plus this green integral. And in place of this green integral, we now have 1 over square root of 224 tangent x over square root of 224. And then obviously we add the integration constant. So this is our final answer. It's not uber complicated, easy, but also not very easy. But I believe it's also an interesting problem. So if you do have any questions in regard to some of the steps we chose to follow, please leave a comment or a question in the comment section. We'll definitely get back to you. But it was really an absolute pleasure to share our version of the solution with you. Until next time, à la prochaine fois.